Okay, last time we checked in was part 2 of the skateboard salvage project, and so it's like picking at a scab or a thread on a sweater. Once you get started, it's hard to stop. So anyway, this is where we're at today. I decided after getting ready to kind of I did a little pre-check and got ready for a reassembly of these trucks. And I was looking at those king bolts and I just thought, they just look skanky. They're cheap parts to replace. I couldn't find them at my local shop, Uprise, that was able to provide me with my bushings and pivot cups and the rest of the hardware I needed. But these king bolts are kind of oddballs, so I went ahead and ordered them from a company I've done business with before, Salvaged Skate. And so those are on the way to me. So what I set these guys up, set them up level so that I could get some of that penetrating fluid right in the top head of these king bolts, because many king bolts have a hex head on them. These have a round head and they're press fit into place. So I wanted to give myself every advantage that I could when it comes to knocking these punks out of there. So since that stalled until I get those parts, I decided why not move on with the deck. So I showed you that beautiful piece of chestnut. I brought it into this from my basement up to the first floor and set it up on these little slats of wood to let air circulate around it and have it normalize a little bit, because the humidity levels are so much different on this floor than they are downstairs. So while that's going on, I went ahead and started working on my template for the pattern of this board. So because this is one and done, I'm not expecting to make any more of these decks, so it's a one-off. So I'm just I use brown craft paper to make my template. Ordinarily, if I'm making multiples, I would do this layout on a piece of 1/8" masonite, or sometimes they call it hardboard, because then I could just use that over and over again to cut out multiple boards. So anyway, I went ahead and laid out the width of my board, laid out the length of it. My length is 36. My width of board is 11 inches, so I pulled in just about 1 inch, a ½ inch in from each side on that. Off my center line, I took my compass and did a circle. I came in and notched out and marked the width of my tail. This is called a squash tail. And then I used this flexible curve to swing that line out to create the taper that you see along this edge right here from the circle, so that that nose comes back about a third of the way on the board, and the tail tapers up about a third of the way up of the body of the board. And then I've just brought those lines together. Now, this is pretty accurate, but in order to make it even more precise, I'm going to use a real simple trick, which is before I cut this out, I'm going to crease it along that center line, fold it in half, and then cut through both sheets at the same time. And that's going to guarantee that these two sides will be exact mirror images of each other. And then I lay that right down on top of the center line on my board, and I'm good to transfer that mark over. So this design is based on a classic surfboard from the 60s, and I think it's going to be a good look with those wheels and those trucks. What else do you need to have on hand to do this? You might like to have a pen for doing your layout, or you might like to use a pencil to do your layout. But remember, anytime you're transferring or marking onto wood, you always want to use pencil. You never want to use ink, because that pencil mark can be erased off of there, but that ink is going to soak into the fibers of the wood, and you'd have to do a lot of sanding to get down far enough to get rid of those ink marks, especially if it's something like a Sharpie that bleeds a lot. A nice long straight edge or straight edge ruler like this is really handy to have, but it's not necessary. A compass is handy to have, but you could find something like a coffee can or a pan or whatever that's the right size circle that you need, and just lay it on top there and transfer right off of that. And again, you don't need it, but it's handy to have, when you're working with a long ruler like this, it's handy to have a clamp to be able to hold the end on it that you're not standing on, so as you strike that line, you got a free hand for marking, and this is not going to wiggle on you. So anyway, I'm going to make my move, fold this in half, cut it out, and then we'll transfer that over to the board. Anytime I'm generating dust, I try and do it outside instead of inside of my studio space. So I've set up this little rig outside, which is a little two-step ladder, a couple of clamps, a brace underneath that to hold my board in place. I've got a speed square, which is going to help me cut a nice straight line on this edge. And I've got my skill saw here. I've set my depth of cut for the thickness of the material that I'm going through so that I don't have an excessive amount of blade exposed. And now I'm ready to go. Notice that I have the weight of the tool resting on the stationary piece that I'm saving, not on the cutoff, so that it's supported and I can handhold that second piece as it drops away. Okay, so what I just did outside was to cross-cut my board, which when we talk about cross-cutting a board, it means if this is the direction the tree is growing, right, and that's how this board came out of it, cross-cutting is when we're going perpendicular, crossing the fibers of that material. And it generally requires us to have a relatively fine-toothed blade in order to reduce the likelihood of it tearing the fibers of the wood as the blade exits. And this is a really important concept because when we go to cut out our pattern, which will be radial or curve cuts, we're going to want to be using a jigsaw. And we're going to want to absolutely make sure that those jigsaw teeth are exiting on what I'm going to call my B side or my waist side, so it's not furring up and tearing the fibers at all. When we get into the jigsaw, we'll talk about some other things that can be done to minimize tear out on wood. So we did a cross cut as opposed to a rip cut, which is running with the grain of the material where there's almost little or no chance of the fibers being torn out because you're moving with the direction of those fibers. So in any case, I like the skill saw for a couple of reasons. One is because I know that it's going to give me a really precise, straight, true cut. And part of what makes that possible is the rigidity of that blade. Whereas a jigsaw blade can flex a little, this blade holds very rigid. But you know, again, you don't need a circular saw like this to make those cuts. It could be done with a handsaw, or if you know, all this could be done with a jigsaw. But I have this available, so that's what I chose to use. And as I mentioned in the clip where I was set up for cutting outside, I like a speed square because it gives me a point of reference that I can abut up against the edge of my saw as I run through the material to make sure that I have a nice straight cut. Right? If I didn't have a speed square, a piece of straight material like this clamped down to the surface would also make a perfect fence to run my saw up against to give me nice straight cuts. So now that we've got that piece cross cut down to the proper length, I can take my, and again, I also wanted this cut to be really straight and true because I want the tail of my board to have that nice, clean, straight line that we build off of. So now I can take my template, which I folded in half, cut it out, and now I can line this up with my center line. I could try to work my way around this, just marking it out with a pencil, but I'd like to have my hands as free as possible to make sure that that template's laying down nice and flat. So I could take a painter's grade tape like this blue tape, and I can run that down along that line to hold that side in place so it's less likely to wander or move around on me. And then I could take that and flip it over and mark out the other side. Or I could also take the template, because it is pretty symmetrical now because of the way that we cut that out, and I could just lay it out, follow my lines, marking them down on the surface. And again, because jigsaw blades teeth face upward, the tendency for the material to tear out will be on the upstroke. So I want to make sure that I'm marking the bottom side of my board, because that way if there's any tear out at all, I'm not going to see that on the top of my deck. So I need to make a decision about what's going to be the top and what's going to be the bottom, and that's largely going to be based on the grain characteristics of the wood, what I think looks best. You might also notice that I have a clamp out on the end of this board. So this is where we made our cross cut. This was that original end of the board. And I talked about this idea of normalizing, allowing that material to stabilize. And in some of the other demos, I've talked to you guys about how, because these fibers are like straws that absorb and displace moisture more readily out the ends, if material dries out or the humidity level changes too rapidly, there's a tendency for what we call checking or cracking, and you can see this crack developing, or this check mark on the end developing and migrating. So I just put this clamp on there as kind of a, as a mitigation measure to try and minimize the further wandering of that. But I've also back set my template, several inches from where that crack was to hopefully minimize the likelihood of it wandering into my piece itself. So, my template will get laid out on the surface. I've got my straight line down on the center, which is also going to make it really handy for making sure that when I lay out my trucks, that they are absolutely in parallel with each other, because I can precisely measure off of that center line for my layout. And I brought out these risers just to kind of play around and look at a little bit about where I want to position those trucks. Remember, the closer the trucks are together, the looser it's going to be. And the further the trucks are apart, the more stable it will be. And again, because of the characteristics of the geometry of these gull wings being that double stack, we're probably going to push these out as far as we can comfortably get them without it compromising the look of the board. So first we're going to go for function, then we're going to tune that up a little bit with look. And again, remember, when you transfer these marks over, use something like pencil, not pen, because that pen ink will get absorbed deep into the fibers of the wood, unless you're okay with just leaving that behind, which I'm not, because I want this board to just be all about the beauty of the wood and not have any kind of, funk going on with it. So I'm going to go ahead and fold this back in half, tape it down, mark up by one side, flip it, mark up the other side, and then we'll get the jigsaw out here and see what we can do about cutting that down. Okay, although I'm being pretty, particular about the way that I do all this, you need to also know that you don't have to be that fussy with it. If you're building for yourself and not building for someone else, then, don't sweat obsessing about all the details, because if this doesn't, translate exactly 100% symmetrically so that the left and right side, match, it just really doesn't matter that much, right? So, if you're not into being real fussy about the layout, don't worry much about that, because, if it's for yourself, it's more important that you have fun and enjoy the process than labor with a bunch of, tediously unnecessary, preparation and and execution. So here's another way to do it, is just lay that template out flat. Put something flat that has enough weight that your paper is not going to slide around. And then you can just come right in from that point. I've lined up flush with my backside, so now I can just come off of that side and work my way all the way around. And you can see I'm not trying to do it in one line. I'm doing it by shading over, and I'm actually going a little bit over the top of the paper, template, and the wood. So what you get out of that is a line that, it's going to be good enough for almost everybody's purposes. So there's no need for you to see me run the rest of this out on camera, but know that holding that paper template down firmly, being consistent about the way that you lay that line into there, allow yourself to ride right up onto that paper as you move down the length, and you can see that's going to give you a line that is, visible enough to follow and clean enough to give you good results. Okay, so I work my way all the way around. I pick up periodically to make sure that I'm getting a good line laid down on the surface. Once I know it's all good to go, then I go ahead and take off that counterweight that's holding in place. And there we have it. So next stop, jigsaw. Okay, so I've got my tools together. I've got clamps securing my board to my work surface. I'm overhanging the edge of my table so that my blade has room to move up and down as it makes that cut. Choosing the right tool is the first step, and in this case, I'm using a good quality jigsaw. I've had this guy for decades, and it continues to perform at levels that are consistent with my expectations. But where I'll really sing the praises of Bosch is for the wide range of blades that they have available to go along with this tool. So, a lot of people think of a jigsaw as a wood cutting tool, but it does excellent work on sheet metal, on plate steel, on leather, rubber, plastics, wax, all kinds of materials. But all that requires us to pick the right blade for the job that you're doing. So we're getting a blade that's designed specifically for wood cutting. I chose something with a high frequency of occurrence of teeth. Remember, if a blade is too fine, the going is really slow when we're moving along with the length of the fibers because it tends to load up with that material. And if it's too coarse, it can have a tendency to rip or tear the fibers when we cross that end grain. So I've chosen something that this is appropriate for the thickness of the material and also for the degree of turn or radius I'm making, because remember, the distance from the front of the blade to the back of the blade determines how tight a radius you're able to achieve. The narrower the blade is, the tighter the radius. The wider the blade is, the less radius you're able to achieve. So for a 1/2 inch blade, that's usually around 2 1/4 inch radius that's achievable with a blade like this before it starts to bind up. Okay, so we think we've got the right blade for the job. Let's go ahead and do a quick review of how to install these blades. And again, remember, if you really want a lot of detail about jigsaws, you can go to the tooth cutting series that I did that is on my channel. All right, so this old school guy secures the blade in place with what's called a grub screw that the screwdriver accessed through the top handle. And newer models have a quick release system that's much easier to use, but this is what I've got. So I always want to install and deinstall my blades with the tool unplugged, just as a safety measure. Left is loose or counterclockwise until I feel that screw kind of hop like that. You can hear that little click. Then I can lay it over on its side. I will take my blade and I'm going to put it in. It keys in perpendicular to the direction of cut. So it goes in, then it rotates, and it aligns with the guide wheel. Then I can go ahead and screw this guy back down till it's hand tight. I want to make sure that my base plate is secure because remember this is adjustable. So I want to make sure it's secured at 90 degrees. I want to make sure that the orbit setting is at either 1 or 2 because most of this cutting is ripping. So when we're doing just ripping along the fibers, we're going to go with a high level of orbit. Remember that's causing this wheel to drive forward as the blade reciprocates to help clear out those fibers. So let's start out with 1 and see how that does. Now that my blade's secured, I'm going to take this little guy, which is it's an anti-splintering device. Because remember I said that as that blade exits, it has a tendency to tear out those fibers. By reducing the space on the sides of the blade, by installing something like this guy right here, which just snaps right into place, it does reduce that amount of tear out a little bit. But I can tell you that it's also, you'll also find that another technique that works really well for minimizing that tear out is, let's see if I can get that to just snap in. There we go. So now that's mounted flush. You can see it's closed that gap up considerably, right? So that's going to reduce that tear out. So another technique for minimizing tear out would be to run tape along that line and mark right onto the tape, and that tape is enough to keep those fibers from lifting up under most circumstances. And again, make sure you use a good quality painter's grade tape so that if you end up leaving it on there for more than a short while, it doesn't leave residue or adhesive from the tape on that surface. Right? So I've inspected my tool, I've inspected my cord to make sure there's no obvious cuts in it. You always want to use the shortest extension cord that you can possibly use because the transfer of current is much more efficient and will extend the life of the tool by minimizing the overheating of the motor of the tool. And the wire gauge needs to always be equal or greater than the wire gauge of the cord that's on your tool. And again, if you're into learning more about this, check out the rewiring project I did, which goes into a lot of the details about how alternating current works. Anyway, so I like this one because it's got a little locking mechanism on the end of the plug that helps reduce the likelihood of it pulling out mid-cut. I want to make sure my cord is out of the way, and I want to make sure that I've got my body over the top of the saw so that I have good control over it. So one hand on the grip and one hand on the head. I'm going to come in from the end. You'll notice that I didn't try to work my way hard up against that line. I eased over towards it. I'm going to run along that, and then I can come back and trim back this other direction. Basic idea. I'm going to go ahead and finish cutting out the perimeter of the rest of this, but I want you to understand, and look, that's nice and clean, almost no tear out along that line. I want you to remember to never withdraw the jigsaw until it's come to a complete stop. Jigsaw done. And moving on to now cleaning up this edge right here. Anywhere that I had a stop and a restart, there might be a little ridge on there. And jigsaws, as they start to go through thicker cross sections, have a tendency to flex a little bit. So to make this line perfectly smooth, I could come in and just use some coarse sandpaper, like a 60 grit sandpaper to knock back that edge, and then come in with subsequently finer pieces of paper, go from 60 to 80 to 120, and knock that back. Again, remember that number 60, 80, 120 refers to the particle size of that abrasive material, in this case aluminum oxide. So the higher the number, the smaller the particle size, the finer the line it makes. So we'd start with that 60 and knock it back, then go to 80, then go to 120. And, you know, all that's good, but you've heard me yakking before about how I really like to minimize the amount of dust that I'm generating, especially when I'm working indoors, because wood dust is a known respiratory hazard. Even the most common of species, like oak and maple, can cause serious long-term health consequences if you're exposed to it for prolonged periods of time or repeatedly. Other things like tropical hardwoods, it could be a matter of minutes of exposure to this dust, and that you could have an allergic reaction to it, or other minor problems like rhinitis. And if you are predisposed to respiratory issues like sinusitis, rhinitis, bronchitis, anything like that, just, you know, you're going to want to take the most strict protective measures by wearing a particle mask, which we all know about now, N95 being the preferred particle mask, because if it's 95 means it can eliminate 95% of the small particulate that presents a potential risk. But, you know, and I made my own sanding block here, which helps keep that nice and smooth and straight and true, whereas if I was sanding this just with a piece of sandpaper in my hand, it would tend to round it over, and I might earn myself a wicked splinter. I could also use, I could buy a sanding block. This is typically used for drywall. It has a foam pad on the back of it, which again tends to round stuff over. I want to hold that nice crisp edge for now. So what I'm going to suggest, because really a lot of what we're all about here is trying to use the tools that are easily accessible and require a minimal amount of investment on your part. Some of these tools I show you just because I want you to know what they're all about, but again, I'm trying to make the focus about what's cheap, easy, and readily available and effective tools. So among those things for me are guys like this. This is called a Sureform. And you can think about it as just being like a cheese grater, right? But the grating part is interchangeable. Left is loose counterclockwise, rotates a pin in here that allows this guy to come off and be exchanged so that it can be replaced when it dulls, and they're very inexpensive. Or it also allows you to be able to put it on with this, with it in this position, or rotate it 180 degrees, because it is a tooth cutting system, and tooth cutting systems only cut on one stroke. So when it's in this position, it cuts on the push stroke. If I reverse it, it would cut on the pull stroke. And we're not going to go into a lot of detail about push versus pull right now, but know that these Sureforms come in a whole bunch of different sizes. They're very inexpensive, and it's a really effective tool. But one of the things that I like about it most of all is that it is like a cheese grater cutting little curls of material away, as opposed to sandpaper, which is generating dust. So little curls, no dust, right? Less of a respiratory hazard, easier cleanup, healthier studio. So you can see it sits right on the top, and I can just gently roll this across that surface, and it will take it down and make any of those ripples on the surface disappear, and the waste material are just these little curls. So part of what also makes this really easy to work on is that I have it clamped into what's called a hand screw clamp, right? So a hand screw like this is a wooden jawed clamp. So we like the wood jaws because it doesn't make marks on the surface of my wood or mar the wood. And here you can get a look at it, right? So it's got these two threaded components that come through and can be adjusted for a parallel relationship, or they can also be adjusted out of parallel if you're trying to hold something irregular. So it's very versatile and very useful for distributing that clamping pressure over a wide part of that board, so it's really secure grip. And it could also be, it could actually be attached to the table with a secondary clamp like this, which would give it even more stability. So don't need it, but I like that you know about it. All right, so I'm going to go around, I'm going to roll all these edges and make them nice and smooth, and then we'll get to talking about what is the next step for shaping up this deck.